Hello students, today we are going to study about the partial differential equations. About introduction, partial differential equations are raised by the applications of laws of physics in engineering and other fields when the number of independent variables is two or more. Alright, an equation in which one or more partial derivatives or an unknown functions of two or more independent variables occurs is called a partial differential equation. So here the important the important notations for the partial differential, the first second order partial differential equation with respect to z. So we have to study this importance equation. So p is equal to dou z by dou x, q is equal to dou c by dou y, r is equal to dou square z by dou x square, s is equal to dou square z by dou x dou y, t is equal to dou square c by dou y square. Alright, then we are moved to the a particular partial differential equations in order to understand more about the partial differential equation. So this is the equation dou square z by dou x square the whole cube is the term is called degree. So this term dou square z by dou x square is the term is called the order of the differential equation. This is the second order differential equation. This is the first order differential equation. So totally we in this total equation we can say this is a second order, the most this is the higher order, that is dou square z by dou x square. So we call second order third degree partial differential equation. So forming of partial differential equation is by two methods, that is the elimination of arbitrary constants and such as a and b, we will discuss in the questions, and by eliminating the arbitrary functions such as f of x y z or g of x y x minus y. So in case some case both f of x and g of y will be present. So we will discuss in details in the other questions. In this lecture we will meet four different questions about the partial differential equation for eliminating the arbitrary constants such as a and b. So consider this equation, we can say this is equation number 1. So differentiating equation number 1 partially with respect to, partially with respect to what is that, with respect to x and y. Alright, so what will get when we partially differentiating with respect to equation number 1, dou z by dou x is equal to, alright, so here a plus here there is no such constant as dou c by dou x with respect to no terms such as x, so it will be 0 and this will be also 0 plus 0. Alright, we already know this is the p, the value of dou c by dou x is p. You should learn this value. Okay, you should definitely learn these values in order to solve the important problems. So should the PQRST. Alright, so differentiating with respect to y, we will get Q is equal to, alright, we can see the question. Q is equal to dou z by dou y, alright, is equal to 0 plus b. So we get the value of a and b, right? So just substitute a and b, p and q instead of a in equation number 1. So equation number 1 becomes z is equal to, what is, px plus qy plus root of p square plus q square. This is the required equation. Alright, so let's move on to the next question. Alright, let's move on to the next question. Question number 2. So this is the question number 2. This is an important question, so we will totally solve 4 questions. And so this is the question. Let's say this is equation number 1. So differentiating equation number 1 partially with respect to x and y. Alright, what will get x with respect to x? 2 into x minus a. Alright, 2 into x minus a with this is equal to 2z into dou z by dou x cot square alpha. Alright, this is what we'll get when we differentiate equation number with respect to x. Okay, let us cancel this 2 from both sides. Okay, and let's write x minus a is equal to, alright, z dou z by dou x is equal to q, right, q cot square alpha. Alright, okay, then we will differentiate with equation number 1 with respect to y. Okay, what we will get with when we differentiating with respect to y, 2 into y minus b is equal to 2z dou z by dou y cot square alpha. Alright, to cancel each other. Okay, so we will get y minus b is equal to z q. Alright, z q cot square alpha. Sorry, we make a mistake here. Sorry, this is not here. Here it is, this value is p. Sorry for the inconvenience. The dou z by dou x is p. Alright, so we always make mistakes, something like that. So in order to avoid the mistakes, you should carefully, sorry, it's my mistake, sorry for the inconvenience. So I will careful to make it. Okay, then we will put the x minus a and y minus b in equation number 1. So what we will get is, we'll get p square cot square alpha the whole square plus y z square, right, z square q square cot square alpha the whole square is equal to z, right, z square cot square alpha. Alright, this cancel this, the z square can be cancelled, so we will get p square plus q square is equal to 1 by cot square alpha. That is simply writing p square plus q square is equal to tan square alpha. Alright, this is the required partial differential equation. So let's move on to question number 3. This is equation number 1. Okay, differentiating equation number 1 partially with respect to x and y. Okay, what we will get with respect to x, 2x by a square plus 2z by c square dou z by dou x is equal to 0. Alright, okay, so we can write this equation as equation number 2. Okay, this in partial differential equation there is no such rules, definite rules. This method is should follow you to solve this particular problem. You can do any method as per your logic information. Okay, as per your logical part works. So you can easily and simply do any any method. Okay, so here this we can differentiating equation number 2 partially with respect to y. Alright, what we will get when we differentiate in equation number 2 with respect to y. So here 2, this value will be 0. 2 by c square is a constant. Alright, okay, first function dou square z by dou x dou y plus dou z by dou x into second function, that is z dou z by dou y. Okay, this is what we get when we partial differentiate equation number 2 with respect to y. Alright, okay, then we will this value it can be not can equal to 0. So we can write this equation. Okay, this is partial differential equation equal to 0, equating 0. Okay, so that is z into dou square z by dou x dou y plus dou z by dou x dou z by dou y. Okay, so we already know this these values of z into s plus pq is equal to 0. This is the required partial differential equation. So moving on to the last one. Okay, this is a very important questions, one of very my favorite and very important question ask in university questions. So you should be very careful when you do in these problems. So nothing much, just put the equation number 1, differentiating equation number 1 partially with respect to x and y. Okay, so here we will get p is equal to dou z by dou x is equal to y plus, okay, so here y into, okay, y into we already know root. Okay, differentiation of root or root x. Okay, what is the value? 1 by root x. right? Yeah, we write this equation 1 by root of x square plus a square, alright, 1 by 2 root x into differentiation of these values. Okay, here will 2x. That's it. We will do the differential equation. Can we cancel the 2 from both sides, numerator and denominator? So we did the equations. So when we differentiating the equation number 1 partially with respect to y, we will get q is equal to dou z by dou y is equal to x plus root of, alright, but we'll get root of x square plus a square, alright. Okay, so this is the we will get p and q. Okay, what we will do is just find the value of x square plus root of from here root of x square plus a square. Okay, square plus a square is equal to q minus x. Just write x in the another side, q minus x. Okay, so we just put this value in here. So what we'll get is p is equal to y plus y x into y divided by, okay, divided by this value, the root of x square plus a square. Instead of root of x square plus a square, we write q minus x. Okay, yeah, so that's it. We we already eliminate all the arbitrary constant. For simplifications we write the for simplification we will write p is equal to, okay, multiply this q minus 5 to the y, so we will get qy minus xy plus xy divided by q minus x. Okay, this xy can be cancelled, so we will get is this, multiply this value into this, that is pq minus px is equal to qy. So for little more simplification, pq is equal to px plus qy. This is the partial differential equation that we will get. Okay, so we will solve for important problems. So this is the homework for you guys. So solve this two partial differential equation and comment in the box also. Okay, I will come with the elimination of arbitrary functions as soon as possible. Okay, so yeah, that's it.